Alright, this is Mr. Gillum, and today what we're going to learn about is the hinge theorem. And it has to do with two triangles and the comparison between its segment sides and its angles. Let's take a look here. And a lot of words. It says, if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. That's a lot of words, and I know there's a few fill in the blanks, so I want you to do that, and then I want you to listen to what I'm saying, because it's not really that bad. Okay, and my little diagram here is missing a little bit of information that might help. Okay, here's how it works. I have here two triangles that have the same side lengths here and here. They're equal. The included angle, meaning the angle in between those side lengths, in one triangle is bigger than the other. The hinge theorem says that because 43 has two equal sides next to it as this other triangle, with only 30 degrees, across from the larger angle will be the larger side. BC must be bigger than across from the 30-degree angle, GH. All right, so there's important things to remember. My two sides that are equal in my comparison, the angle must be in between them. Included is what the word is for it. Must be included. All right, and so if that included angle is bigger, the side opposite is longer. If it is smaller, the side opposite is smaller. The converse, in a lot of words, says if two triangles are, two sides of a triangle are congruent to two sides of another triangle, and the third side is longer than the second, or the third side in the other, then the included angle in the first is greater than the included angle in the second. So once again, it's very interesting how you do it here. If we have the same side in both triangles, that is an equal distance, or equal length, and this guy is an equal length, then the included side, the last part of the triangle, where it doesn't have to be the hypotenuse, the last part of the triangle, in comparison, if it is larger, in this case 12, then angle R would be bigger than across from this smaller angle, angle L. All right, but in order to use the hinge theorem, you need two sides that are of equal length. The hinge theorem or the converse of the hinge theorem, you need two sides of equal length. The hinge theorem itself says if you have those two sides of equal length and the angles are different, the one with the bigger angle has a bigger side opposite. The converse says if it has a longer side, then the angle is bigger. All right, so we're going to put this to test here, and I think once we get some examples, it'll make more sense. And I went ahead and typed up the explanation and not so confusing words, hopefully. If I compare WX and XY, all right, and I have this diagram here. What I'm looking for to use the hinge theorem, before I can use it, I need to make sure that I have two sides that are equal. And what I see here is I have this side and this side that are equal of these two triangles. And the other one's not quite so obvious. The other one is the one they share, the side that they share. Okay, and so I do have actually two triangles here that have two exactly equal sides to them. Now I compare the included angles, 51 and 55. The hinge theorem says that across from the 51, since it is included between these two equal side lengths, must be a smaller. So this guy right here, because it's across from a 51, must be less than this guy here, because it's across from a 55. So if I compare this yellow one to this tan one, across from the 55, a bigger angle is going to be a bigger side. So if I compare WX with XY, I know WX is shorter than XY. So it is smaller than or less than. Okay, and I'm going to go ahead and compare these next ones as well. Once again, sometimes it's hard to tell if the hinge theorem is applicable because we need to make sure that there is two sides that are exactly equal in these triangles. And in this case, this side and this side are perfectly equal of these two triangles, and they actually share a side as well. That guy right there. So the angle on the top triangle, that would be the hinge angle, would be this guy, the one that's included. And the angle on this guy, that is the hinge angle, would be this one right here. It's the included one in between the two sides that are shared. Okay. Now, to tell which angle is bigger, I simply look across from the angle. because across from this guy is a 3 and across from this guy is a 3.6, I know the yellow angle must be bigger than the pink angle. So in this case, I'm looking at angle FCD, and I know that it must be smaller than angle BFC. All right. I know this because when I look at the included angle, across from it is a bigger number. Okay. So now we're going to go ahead and use inequalities to find the possible values for x. So once again, we're going to use this new hinge theorem to help us do this. What I'm going to do is I'm going to take my little marker. I'm going to make sure that the hinge theorem is applicable. I see one side that is marked with this little signature right here, and this side are marked. So that means they're equal lengths. They also share a side here in the middle. All right. They share that side in the middle. So they do have hinge angles here. And what I know about the relationship between these angles is this is one of the included angles, and this is one of the included angles. Now to tell which one is bigger than the other, I need to look across its opposite, right there, and it'll tell me which one is larger. So using this information, I know that 11 is bigger than 9. Therefore, 6x plus 15 must be bigger than 65. Okay, and so when I'm trying to find the possible values for x, I can just simply solve for x. Oh my goodness, let's see here. That'd be 8 1/3. X is greater than 8 1/3. You might see even x is greater than, oh, that would be 25/3. Would be fine as well. Okay, so this is a comparison that we're doing, the range of possible values for x. Anything bigger than 8 1/3 will be a possible value for x because this is guaranteed to be bigger than this. So any of those values will give us a value bigger than 65 degrees. All right, just want to do one more here. The first thing I need to do is always make sure that my hinge theorem, since that's what we're practicing, my hinge theorem applies. And this one, let's look at, I have given to me that this segment and this segment are equal of these two triangles. And I need to find the second one that are equal. Now this is going to be tricky for me. It says that in this case, they're not sharing a side like the other ones, but I know that they're equal right here and right here because they both say 50. So they must be equal. So now I do have hinges. I have hinge angles here. My hinge angle that is included would be this guy and this guy. Now I need to decide what the relationship is between them. Okay? Because I see that across from my 55 is 5x plus 2, and across from my 68 is 47. The angle, the segment length across from 68 is going to be bigger than the length across from 55 because 68 is bigger than 55. So I know that 47 must be bigger than 5x plus 2. All right, and so I'm going to go ahead and solve this thing. So I know 9 must be bigger than x, or I would prefer you to write it x is less than 9. So the range of values for my x value, according to the hinge theorem, says that x must be less than 9. If it was 9, it would be 47, which would be equal, which we know couldn't be the case. So the first thing less than 9, let's just use a whole number, would be 8. 40 plus 2 would be 42, and 42 is less than 47. So that anything 8.9 would make it true, anything less than that would make it true. Those are simply the possibilities, thanks to the hinge theorem. Okay, so that's the hinge theorem and the converse of the hinge theorem, and that's it for today.